right, answers for these. I think that's going to be the easiest. As you take a look, I just want to make sure, just give you an opportunity to double check, make sure you're doing right, and then figure out if we are doing them wrong or getting wrong answers, how we can fix them. So for the first one, you get 22.6 degrees and then 157.4 degrees. Second one, 113.6, 246.4. For 3, cosine theta equals 0.75, 0.7227.
So for formatting answers, like usually when we deal with radians, we have them in terms of pi. So if we're not able to put them in terms of pi, it's fine leaving it as a decimal.
Yeah, because right here,
There's no way.
These values are not
like
square root of 3/2. They're not. You got to do decimals.
Okay.
And then 5.5605. Now, usually you're putting numerical order, smallest to the highest. It doesn't really matter though. I'm not going to mark anything off. And then that last one, 2.1745, and then 5.3161. Okay, for that. All right. Like I said, double check, because sometimes, like I said, when you get these negative answers, that can be a little bit confusing. Any one of these be helpful to go over. Okay. So double check. What did you get? Don't we get a negative initially for tangent? Yeah. Negative what? What does it get? 0.9 something.
0.967.
Claire?
In the first two, how do you get the second one?
You're okay with these two getting the second number?
Yeah.
Okay. So get the second number here. Let me check what mode I'm in. I'm in degrees. So you use your calculator and we do inverse sine of 0.385. And it gives us 22.6 degrees. There's two answers from 0 to 360 that'll work. The second answer is based upon which quadrant it's either, in this case, the positive in. So which quadrant is sine also positive in? Okay, second quadrant. So it's positive in quadrant 2. $22.6 degrees. All right, so it's in positive quadrant 2. That means you need to get the reference angle and then use that. So that means 22.6 will be our reference angle. And then you do 180 minus 22.6, 157.4. Okay, for that. So now let's see here. So if I use the actual angle and I do 180 minus that, okay, so that would be without rounding off. All right, so understand, what if you take the sine of that angle? What should our answer be? Anybody? If I take the sine of that angle, what should our answer be? 0.385. Okay, so we're going backwards. I'm telling you the sine of some angle is 0.385, and you're figuring out the two angles that it works for. One of them will just do an inverse sine. Okay, that'll automatically give us 1, but we have to find the second one, because remember, when we did inverse functions, we restricted the values that can come back so I didn't get multiple values back. But here, I'm required because I've given the interval from 0 to 360. Okay, other questions on here? All right, good. Now, we went through those. I know you didn't have to do 57 or 63. 49 should have had 3 pi over 2 as an answer, because that came from sine of x plus 1 equals 0. So sine of x equals -1. That's going to be 3 pi over 2. That's the only spot that it works. Or 270, -90, all of those are fine. You can use your calculator. Now, if you just want to verify, like I'm in degrees, but you got this inverse sine, -1, -90, which would be 270, which would be 3 pi over 2. Okay. Anything else, though, homework-wise? Need to look at. All right, we get it. Yep.
Can you do a 51?
Yeah. What does it look like? 51.
2 times the cosine of x plus 1. And then square root of 3 times tangent x minus 1.
Like this?
Yeah.
Square root of 3.
Tangent x minus 1
And
equals 0.
equals 0. All right, you got the two parentheses. They're multiplied together.
That's not 51, that's 50.
Uh-oh.
51 was cosecant x minus 2
Maybe
times
that's why.
cotangent.
So you just did the wrong problem.
Yeah,
It didn't work
that'll
out?
do it. That'll do
Alright.
it for sure.
All right, so you probably did this one right.
Probably.
All right, so wrong problem. All right, so you guys are all, that's like kids looking for your books. All right, so you got a different problem too? For 51. All right, wrong problem. So we're good then. All right, anything else?
Can you do 45?
Yes. What is the original?
Square root of 3 times the tangent of x minus pi over 6 minus 1 equals 0.
Did you say minus 1
Yeah.
equals 0? All right, I'm going to let theta equal x minus pi over 6. We'll let that happen. And then it's going to be just square root of 3 tangent of theta. I'm going to move that 1 over, equals 1. And then that's a theta. Tangent of theta equals 1 over square root of 3. Okay, at this point, you don't have to rationalize the denominator. I mean, you can leave that, it doesn't matter. But I mean, I know you're so used to doing that because we're not solving for that. So what is that? It's either got to be a 30 or a 60. And you're not going to be as familiar with tangent, so you might just want to draw out what is 30 degrees. 1/2 square root of 3 over 2. 1/2 divided by square root of 3 over 2. 1/2 times 2 over square root of 3. All right, 1 over square root of 3, that's going to be the same thing. So it's got to be a 30-degree reference angle. Where is tangent positive at? It's positive in quadrant 1 and what other quadrant? 3. So that gives me this 30-degree angle, which is 210 degrees. And that's 30 degrees. Well, in radians, pi over 6 and 5 pi over 6. So theta, pi over 6, theta equals 5 pi over, not 5 pi over 6, 7. 7 pi over 6. But we're not solving for theta. What are we solving for? X. And so we replace x minus pi over 6 here. And then I'm just going to solve for that. And x equals 2 pi over 6, which is pi over 3. Okay, so you got that one. And then the other one, same thing here, x minus pi over 6 equals 7 pi over 6. Add pi over 6. 1 pi over 6. So you get 8 pi over 6, which is 4 pi over 3. So, and I use, some people don't use a substitution, they just keep it like that, and in the end, still that's fine. It really is. Just make sure you don't make a mistake. And what by that, I mean, sometimes we'll just leave it as tangent of x minus pi over 6 and split it up, which really isn't an issue. All right, anything else? All right, there are a lot of different types of equations that we're going to come across. And this is kind of, we're going to finish up like the different types you're going to see. No guided notes, go ahead and get out. Sheet of paper, let's go through a few here, just make sure we cover them. All right, we talked about this yesterday. If A is between -1 and 1, you're going to get. I got it going. Thank you. So perfect. A is between -1 and 1. You get two solutions because of, oops. And so if -1 less than A is less than 1, you're going to get two solutions. Always. One solution if A equals 1 or A equals -1. And then no solutions when A is greater than 1 or A is less than 1. That's for sine and cosine. But what did we say about tangent? The A value for tangent. It could be what? Any number, and you're always going to get two answers for tangent. So if you got tangent of x equals 1/2, you're going to get two answers. Okay, if you got tangent of x equals 3.5, you're going to get two answers. Okay, it doesn't matter. Just for tangent and cotangent. Sine and cosine, you're limited. Okay, because of their graphs. All right, did we do this one yesterday?
Yeah.
Or we just, okay. All right, well, let me just do, I'm not sure if I got to with the other class, I'm just gonna do it again, won't hurt anybody. All of these are gonna be over the interval 0 to 2 pi, all of these are gonna be radians. I think I got it for each one, but just let me reinforce that. So you got sine of x minus 1 equals 2 times cosine of x minus square root of 3. It is in what we say factored form, you got the parentheses together, which is nice. So you just sine of x minus 1 equals 0, add 1. Sine of x equals 1. 2 cosine of x minus square root of 3 equals 0. Add square root of 3, divide by 2. All right, this is where the case we get one answer. Sine of x equals 1. Because where's your y value equal 1? That's at 90 degrees or pi over 2. Where does cosine of x equal square root of 3 over 2? Okay, that is positive, so it's going to be in quadrant 1, quadrant 4. So that's going to be square root of 3 over 2. That means that's got to be a 30-degree angle because this is 60. So you're going to get 30 degrees. This will be a 30-degree reference angle. That's going to be 330. So that is what, pi over 6 and 11 pi over 6. And then for your final solution set, you kind of put them in order. Pi over 6. Okay. If it's like that, nice. They already did the hard work for you. Okay. All right, now, like I said, we're going to come up with several different types in terms of how they look and how we go about solving them. So for this one here, cosecant squared equals 2. Cosecant squared equals 2. We don't like to work with cosecant, so we're going to convert it to sine. Sine squared is going to equal 1/2. We'll do that. All right, what do you do with anything squared? Like you've got x squared equals 9 or x squared equals 16, you take the what? The square root. So we're going to do the same thing. We take the square root. So square root of sine squared x equals plus or minus square root of 1/2. That's going to be important because you still got to do that. It's going to be positive or negative. Well, square root of sine squared is just sine of x. All right, plus or minus square root of 1/2. Well, what's the square root of 1/2 simplified to? Well, that is 1 over the square root of 2 because square root of 1 is 1. And then what do we do? What do we get when we rationalize that denominator? We get square root of 2 over 2. So sine of x equals plus or minus square root of 2 over 2. So that's going to be all quadrants. Where does it equal positive square root of 2? Where does it equal negative square root of 2? What's your reference angle? Okay, for radical 2 over 2, it is 45. But it's going to be in every quadrant because we need both the positive and the negative. Okay, and so it's going to be pi over 4. Pi over 4. 3 pi over 4. 5 pi over 4. And 7 pi over 4. Okay? Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So if you take the square root, you got to watch for the plus or minus. Make sure you account for that. And like I said, all of these will have a reference angle of 45 degrees. Okay. For that. All right, so that's one with a cosecant square. Cosine, 2 cosine squared x minus cosine x minus 1 equals 0. Yeah, it is. Square root won't work. But think about this. What if I had 2x squared minus x minus 1 equals 0? You basically have a quadratic. What do you do to quadratics? Factor them. They don't factor, use quadratic root formula. So we got to factor that. So if it helps you think of just in terms of x squared minus x minus 1, that's fine. So what's that going to factor into? So it's got to be a 2x and an x. And one's got to be plus and one's got to be minus. All right, I got 2x plus 1 times x minus 1. Does that work? Okay. Now, instead of x, so we really use what? Cosine of x. Cosine of x. So I got 2 cosine of x plus 1 times cosine of x minus 1 equals 0. So 2 cosine of x plus 1 equals 0. Cosine of x minus 1 equals 0. And then just solve those independently. I get subtract 1 divided by 2. Cosine of x equals negative 1/2. Cosine of x equals 1. All right, take a second. Try and figure those out. Without using your calculator, did I count you? You can just do inverse cosine of 1/2, inverse cosine of 1, or negative 1/2. Okay, and you should be able to come up with at least the degrees. All right, we'll basically think of it like we did over there. It's like x squared minus x, 2x squared minus x minus 1. Okay, so here, let me go. All right, so for that factoring part, so if you got 2x squared minus x, so is it minus 1? Yeah. Don't forget, this is probably how you usually do it. You take 2 times negative 1. Remember you did that first times the last, which is negative 2. And I need 2 numbers that multiply to equal negative 2 and add to get negative 1. And then that would be what? Negative 2 and 1. And then a lot of you do this grouping method, which is fine. 2x squared minus 2x plus 1x minus 1 equals 0. And then GCF of 2x, GCF of 1, 2x times x minus 1 plus 1, x minus 1. Times 2x plus 1. Remember that?
Yeah.
All right, so that's all I'm doing. So you might want to rewrite it when you got a cosine squared and a cosine. So that's like a squared term, that's a linear term. When you don't have a GCF for all three, so you just can't factor out a cosine. You got to go this route. Okay. And now once I have here negative 1/2, Mackenzie Donahue, what do you get for that?
I had, you want my radian?
Yep.
Okay, I had 2 pi over 3 and 4 pi over 3.
2 pi over 3, which is 120. 4 pi over 3. And now cosine x equals 1. That's going to be, what's that answer?
2 pi.
All right, here's what you got to watch. And you're not wrong. It is somewhat 2 pi. We use 0 because everything is defined. If you take a look, it's always defined. We include 0, we can include 2 pi because it could be either one, right? So we don't want to include both of them. So it's 0. So when you have that, put 0 down. And so you do have 3 answers: 0, 2 pi over 3, 4 pi over 3. Okay, 4 pi over 3. So you got to factor that. All right, there's that factoring. All right, since factoring is, this will be the same type of problem. Take a second, see if you can factor it. I'll go through it in a minute. Let's see what you come up with. And if it helps you, think of it as 2x squared minus 5x plus 2 equals 0. Okay, when I take a look at this now, I know you can do grouping, that'll always work. Just like when I have a small number in front of the x squared, I just like to do guess and check. I got a 2 here. I don't have many options. These two numbers have to multiply to get 2. Since that's a negative, both of them have to be negative. So it's either 1 in the first slot and 2 in the second, 1 here or 2 here, or 2 in the first and 1. But if we try 1 and 2, okay, and you check with the FOIL, you get -4 and -1. It gives you -5. Now I just take the x out and put in a sign. 2 sine theta minus 1 times sine of theta minus 2 equals 0. And now break those apart. Set each of them equal to 0. So 2 sine of theta minus 1 equals 0. Sine of theta minus 2 equals 0. All right, I get sine theta equals 1/2. Where's sine theta equal 1/2? 30 degrees, which is pi over 6. 150 degrees, which is 5 pi over 6. So we get pi over 6 and 5 pi over 6. So theta equals pi over 6, 5 pi over 6. All right, for my second one, sine of theta equals 2. Okay, What about that situation? Can't happen. Can't work. There's no angle that has a sine equal to 2. No solution for that one. So you're just your two answers. Okay. Pi over 6 and 5 pi over 6. So that can happen. Not a big deal. We can only solve for the 1. So those would be your two values. All right, so that's factoring. Okay, being able to take something, factor it. Okay. Oh, this is a good one. 2 sine squared minus cosine x minus 1. Two sine squared x minus cosine x minus. All right, huge problem. What's the huge problem? We got sine and a cosine. You can't factor this at this point. All right, you want them in terms of the same function. We can make them in terms of the same function by using a little substitution. We can take sine squared out and put in what? 1 minus cosine squared. We want to get them in terms of the same angle. So we know sine squared x is the same as 1 minus cosine squared x. So I take the sine squared out. Okay, so we get that. Distribute your 2. Distribute your 2. We're going to have to do a little bit of work here. Okay, and so it gives me 2 minus 2 cosine squared x minus cosine of x minus 1. All right, you're going to get a quadratic because you got 1 cosine squared, you got 1 cosine of x in linear term. I always want my my leading term to be positive. I'm going to move everything over to the right. You also have a 2 and a negative 1. We'll deal with that because that'll combine together. I'm going to move everything over. And it's going to be 0 equals positive 2 cosine squared x. This minus becomes plus cosine of x. Okay, that minus cosine of x does. All right, 2 minus 1 is 1, but I move it over to the other side. So it becomes a minus 1. Now factor it. And just to save a little time, I'll just go through it. We'll start with 2 cosine of x. Cosine of x. What do your signs have to be if it ends with a negative 1? There have to be one positive and one negative. Okay, you just have to figure out where the plus goes. And the only way to get 1 is to multiply two numbers is 1 and 1. So I believe this is going to be a plus 1 for the first one. Nope, it should be flip it around. Make this a minus 1. Make that a plus 1. Because the 2 cosine of x will give you plus 2, and that minus 1 cosine of x give you minus 1, which adds up to plus. Now set each equal to 0 and solve. So 2 cosine of x. 2 cosine of x minus 1 equals 0. Cosine of x plus 1 equals 0. Oh, what do I get here? Cosine of x equals positive 1/2. Cosine of x equals negative 1. X term is 1/2. So say it's a 60-degree angle, pi over 3, because it's in the first quadrant. And what would be my one that's in the fourth quadrant? 300, which is something. 5 pi over 3. 5 pi over 3. And how about cosine of x equals negative 1? Ooh, do you know that one? Logan? Pi. 180 degrees. Okay, pi. Okay, and so I got x equals pi over 3 pi. 5 pi over 3. Okay, pi over 3, pi and 5 pi over 3. All right, let me just set this one up. Well, we'll see the time. If I got time, we'll finish. 3 cosine squared x equals sine squared x. All right, yeah, this one isn't too bad. All right, let's see if we can get through this. 3 cosine squared x equals sine squared x. All right, we're running the same issue. We got a cosine squared, but we have a sine squared. We're going to have to use a substitution. Doesn't really matter which one because they both can be substituted in for. I think let's just go with cosine squared x equals 1 minus sine squared x. So that becomes 3 times 1 minus sine squared x equals sine squared x. All right, distribute the 3. All right, they're both sine squares. You think how we want to handle this? Okay, think how we want to handle this. This would not be like the last 2 or 3 where you have a sine squared and a sine. We're going to go ahead and add 3 sine. We're going to combine these like terms. So add 3 sine squared x. I get 3 equals 4 sine squared x. All right, what did we do with the one problem that just had something squared? We took the what? Square root. So we're going to take the square root, but first I'm going to divide that 4 over. And I'm just going to flip the, I like my sine squared on the left, so I'm just going to flip the order. I'm going to put sine squared x equals 3/4. I basically divided both sides by 4. Take your square root. And when you do that, you're going to get plus or minus 3/4. So I get sine of x equals plus or minus square root of 3 over what? 2. All right, think about those. You got 4 answers. List them. So you're thinking what you're, the square root of 3 over 2. So if you're thinking in quadrant 1, reference angle has to be 60 degrees, which is pi over 3. Two pi over 3. What else do we get? 4 pi over 3. And then 5 pi over 3. Okay, 5 pi over 3. All right, now there's the last one. I'm not going to go through this last one. I'm going to explain it for a second. This one's a little bit more complicated. I got the workup. This is, like I said, more on the advanced level. You're not going to see one like this on the test, but I'm going to have it up here on the guided notes. I'm not going to go through this, but this is a case here since I got a square root of 3. I don't have any squares in here. In order to get to a substitution, I got to create a cosine squared or a sine squared. So once I get to that, I can do a substitution, then I have a factoring problem. All right, I'm going to leave it obviously on the guided notes so that you have that. You won't see anything that difficult on the test, but those of you who do really well, you need to see that just so that you have that. All right. Now, the very last problem on this assignment is one like that. So you can try it, but it's not something that I'm going to be checking. Okay, so 81 is going to be a little bit like that, extremely similar to it. But those others. There are a few problems there, but you need that repetition. Okay, you got to go through this because there's so many different ways, or different types of equations that can be given to you.